So what we're going to do now is we're going to study Gay-Lussac's law. Gay-Lussac said that temperature and pressure are directly relevant to each other. Yeah, so they're linear. And one doubles, the other will double as well. Now, just a reminder, we have to remember that temperature, we can't think about it in Celsius or Fahrenheit. We have to think about it in Kelvin. So if we were to say the temperature were to double or go up by 10%, we have to study that in Kelvin. Just a note. Let's continue on. We're going to study Gay-Lussac's laws, and we're going to see here that I've got this really cool pressure vessel. Actually, I have to show you how cool it is. This is just an accumulator because it's small, and I had this designed so that I could actually study some chemical processes under pressure, which are pretty cool. So what this is, it's so cool. There's a top here with a rubber seal, and this thing's just completely empty. We'll just check it. See, it's empty. There's no magic in here. And this goes on here, and then I'm going to put this back on here, and it holds pressure. I haven't taken this thing up past 100 psi. Actually, I probably haven't taken it up past 50 psi. But I imagine it could. It's stainless steel, and I had it built out of stainless steel because of the chemical process. I didn't want anything else going in there to react with it. So I'm just going to close this up. And what we're going to do is we're going to pressurize the air inside of here. We're going to study the temperature. And then we are going to stick it in the freezer and cool it. And we'll see that the pressure actually goes down. And then we're going to heat it, and we'll see that the pressure goes up. I'm going to put a very specific amount of pressure in here, and we're going to study it with this probe. So I've actually got this probe. There's a thermocouple on the end of here, which is really cool, and you'll study thermocouples next semester in Mechatronics 2. So there's a thermocouple in here, and it's studying the temperature in here, and it's being displayed here. So it's 29 degrees Celsius. Now the pressure in here right now is next to nothing. It's 0.35 psi. We're going to put air in here, and then we're going to study the pressure and watch the temperature. So we'll actually see that the temperature may go up a little bit when I put pressurized air in here, because pressurized air is actually warm. And we'll talk about that when we get into compressors. So now, how do I put pressurized air in here and then make it stay here and then remove my pressure source? Well, I use a check valve. So this check valve is designed to let air go in this way, and it can't come out this way. So I'm going to connect this to the compressor. Now, I'm not going to turn my compressor on because it's already charged. I'm just going to turn my regulator up and just put a little bit of pressure in here. So let's watch to see how much pressure I put in here. I'll put about maybe a maximum of 20 psi. So now this is leaking, so I can hear it leaking. So I'm going to turn this down, and I'm going to open this up, and I think maybe I didn't clamp it properly. That's probably what's going on, because I know it's sealed very well. I've used it many times. Okay, so now that's nice and clamped. Let me turn it up now. Okay, so I got a problem. I don't know what's going on here. Let's check it out. Coming from this side. You know, pressure leaks, it's easy to find them because you can feel them. They're great. And, you know, pneumatics is so amazing. So when it does leak, well, it's not toxic, it's just air. So hydraulic systems, although they're really powerful and really cool, they have lots of really good applications. The problem with hydraulic systems is they're dirty. When they leak, they make a mess. So I'm just going to make sure this goes on here properly. There, it's seating a little bit better now. Now I'm going to put my clamp on. Let me put the clamp on, and then I'll seat it. You usually stand it straight up. Here, let me put this on the edge here. There you go. Now I'm better. Okay, now that is sealed well. There, that's a nice seal. Okay, here we go. I was trying to avoid messing with the temperature probe and pushing on it, but the edge of the table here is helping. Okay, good. So, we've just fixed the seal. We did a little diagnostic. I put my finger there and I felt where it was coming from. Now, I also knew that the only way it could come was from the seal, because the threading in here, this MPT threading, has got tape on it as well, so Teflon tape. So here we go. Let's see what happens. Okay, so now I've got it up to 17 psi. I'm going to kick it up to maybe, say, around 20. Now, when I turn this off, it'll actually come down a little bit, but it will stabilize. Okay, so now we'll wait until it stabilizes, and we're going to go for 20.5. May go down to 4. It's fluctuating between 20.45 and 20.5. So that's a good number for us. 20.45 to 20.5. We can just go with that. I mean, I think when we study the difference here, we're going to see PSI or maybe half PSI. So 0.05 PSI is not going to matter. So right now, just to make a first reading, we've got 29 degrees Celsius at 20.45 degrees, PSI. So now, let's stick this in the fridge. But what I'm going to do is I'm going to disconnect this, and because it's a check valve, it's not going to affect anything. There we go, didn't change. Okay, so let's put this in my freezer, and we'll go from there. So we still got 20.45. We haven't lost any pressure. It's actually still fluctuating. Now let's stick this whole thing in the freezer. Now this thing is actually designed for an oven, so it can actually go in here, and this can be crunched off. So I'm going to put this guy in here, and we'll see if I can get this hose like this. Okay, let's let it cool down. It's already gone down to 24, 23. You can watch it. Now, let's watch the pressure. Now we've lost more than half a PSI, and we've gone down several degrees Celsius. But it's quite remarkable to see it in action. It's actually really happening. I'm just thinking of Gay-Lussac now, in that the experiments he must have done, and the types of things, he did this in the late 1700s. So the types of equipment that he was using I'm not sure how he was using it, but I mean, he was studying pressure and he was studying temperature. And when he, were to be doing these experiments, and then he would see the results, like what's happening now, that must be incredible, because it was like really the first time anyone locked their head around and actually studied and measured what was happening between the pressure and the temperature of air. So it's gone down quite a bit, so I'm going to let it go down to 19.5, and then we'll say that it's gone down a full PSI. We'll let it go down to 19.45, and then we can say it went down 1 full PSI. And we're going to take those measurements, and then we're going to heat it up. Then we'll see if we can study this in the gas law to see what the actual volume is. We'll stick it into the general gas law. Okay, good. So we've gone down 1 full PSI. Now, let's stick this thing in the oven and see what happens. Right now, it's starting to go up. Actually, let me put my hand on this and see what happens. So my hand is warming it up, and we'll see if the pressure goes up. I'd say that would be a pretty cool thing. If we actually wanted to study the temperature of something that was pressurized, we could actually just figure out what the pressure was, and or vice versa. If we wanted to know what the temperature was, we could actually study the pressure, and then you could calculate the pressure. Okay, good. So you could calculate the temperature, pardon me. So look, it's gone up just with my hand on here. Plus, the ambient air was actually 28 degrees before. So now, I don't know how warm this is, but it's actually pretty warm. So I'm going to put this guy in here. Okay, now I'm going to close that off, and maybe I'll just leave that. I think it's okay. It's not going to burn anything up. Okay, so now let's study this and see what happens. Let's watch this in action. Okay, let me just get these. Okay, so, well, it's going up. So the temperature is pretty hot in there, it's 35. Now that lead is just against the side of the container. So it's not actually telling the actual temperature of the air inside. I'd have to actually design a different vessel with the temperature sensor inside touching the air only. So it's a little bit delayed, so the air in there is changing at a different rate than the actual temperature of the probe. So even though it says it's 43 or 44 degrees Celsius, the probe, I would say that the air inside is probably only 30, or I'm not sure what it is. But we can see it's going up. It's actually gone up to 21. So let's see if we can make this thing go to 21.5, and then we will go up a PSI. After that, I think I'll stop because I don't want to burn up the hoses and stuff. Okay, good. So we've gone up. So we've demonstrated the fact that temperature and pressure are linked together. They're directly proportional. If one goes up, the other goes up. If one goes down, the other goes down. It's quite remarkable. I'm loving this. Okay, bye.